Hi, this is Ashutosh and welcome once again in this course of indefinite integrals in which we are in now lesson number 11, which is polynomial multiplied with power linear. So actually this is the heading, but this is the form of integrand we can see, and we will apply the substitution method to deal with this kind of integrand. So let us try to understand what is this. So suppose I have any polynomial px times the linear ax plus b to the power n. So you can see the topic that the polynomial multiplied with powered linear. So the power linear means that there is a linear thing ax plus b, and on which there is a power n, and of course n can be any real number, and this px is any polynomial of degree greater than or equal to 1. So whenever we see this kind of integrand, we have to substitute this linear as t. So this t is equal to x plus b. The second step we can do, we have to write this x in terms of t, and t will be t minus b by a from here, and substitute this x into the polynomial. Means we see this is the polynomial, and here we have to substitute t minus b by a, and of course that the linear ax plus b we have to write t as well, and after this we have to do the integration. So let us try to understand the whole thing with the example. So suppose I have the polynomial as p, this is what px, 2x square plus 3, and this is the linear ax plus b. So you can see the power is half here, because the power can be any real number. So of course x plus 2 can be substituted for t. So this will be t is equal to x plus 2, so dt will be dx, and so the x will be t minus 2, because we have to write this x in terms of t. So now in the polynomial we have to substitute x with t minus 2. So this will be 2 times t minus 2 the whole square plus 3, and of course this will be root t. And now you can see that this will be very easy to handle, because we can expand it. So the expansion will go like this: t square minus 4t plus 4 for t minus 2 the whole square, and plus 3 is here, and 2 actually of course. So this root 2 will be multiplied with each of the numbers or each of the terms in the bracket, and so it will be 2 times to the power 5 by 2, 8 times to the power 3 by 2, and 11 times to the power half. And now we can integrate it easily, and the integration will be this one. And after the simplified the simplification of the integral, we can substitute t as x plus 2. That was the original value or original expression we had written for t. So that is the answer for this question. So again let us apply the same thing for this example. So suppose this example is 2x plus 1 times root over x minus 1. You remember this is again the form of linear times root linear, and this was discussed with in the algebraic transformation. So you can see that whenever linear times root linear is appearing as the integrand, we have now two kind of or two different techniques to handle. So the first is whenever see this is algebraic transformation, so this can be also done with algebraic transformation. So you can go to the same topic, and you can see how we have handled this with this technique. So this is what algebraic transformation, but here we are discussing to handle this kind of integration with the help of substitution. So of course this is x minus 1, which is the linear part, and this can be treated as the polynomial. Of course this is a linear, of course, but this is the polynomial we can treat. So t is equal to x minus 1, and dt will be dx. And since we have to substitute x, we have to write x in terms of t. So x is equal to t plus 1, and putting there we will get 2t plus 3 there in the bracket, and of course root t is there. We have to multiply with root t to each term, and we will get this as the final integration in terms of t. And since t was x minus 1, so we will substitute it back to get this as the answer. Let us do some more complicated example, in which here you can see this is not so complicated, but still. So suppose this is x square over 3x plus 1 the whole power 3 by 2. So this is in rational form, but again we can see that x square times 3x plus 1 to the power of negative 3 by 2 can be written for this rational. And we can simply see that x square is treated as the polynomial, and this is the linear part, and the power is negative 3 by 2 because it can be any real number. So 3x plus 1 should be taken as t. So t is 3x plus 1, so dt by 3 will be dx now, and also the x is t minus 1 by 3. So this x square should be replaced by with t minus 1 by 3 the whole square, and the linear part 3x plus 1 should be replaced with t, and the dx should be replaced with dt by 3. And of course, after simple manipulation, we will get 1 by 27 as the constant, which can be taken out, and the t minus 1 the whole square should be expanded with the help of identity to get t square minus 2t plus 1, and this t to the power negative 3 by 2 can be now multiplied with each of the term of the parenthesis to get t to the power half minus 2t to the power negative half and t to the power negative 3 by 2. And after the integration, we will get this integral, and of course t is equal to 3x plus 1. We will substitute it back, and that is the correct answer for this integration. Let us take this example, and in which the power of this x is 3. So you can see the complexity when the power increases. So here x cube plus 1 divided by x minus root of x minus 1 is given. So of course x minus 1 should be taken as t. So t is x minus 1 and dt is dx. So this x can be written as here, this x can be written as t plus 1 the whole cube, and this root x minus 1 can be written as root t. So of course after expanding it, we will get t cube plus 3t square plus 3t, and this 1 and 1 will get added to 2, and by root t. So after just separating it, we will get t to the power 5 by 2, 3t to the power 3 by 2, 3 times t to the power half, and 2 times t to the power negative half. And after just integrating, we will get this as the integration in form of t, but t was x minus 1, so we will substitute it back to get this answer. So you can see when the power was 3 so we can see that the expansion will be more complicated, and when we increase the more power or the more terms into the polynomial, we will have the extent of complexity increased. So suppose this is example x cube plus 3x square plus x plus 1. So we will substitute t is equal to 3x plus 1 and dt is 3 dx. So of course x is equal to t minus 1 the whole t minus 1 by 3, and we have to substitute x here, so that will become t minus 1 the whole cube by 27 and plus 3 t minus 1 the whole square by 9 t minus 1 by 3 and 1, and of course this integration will be more complicated. So you see that the higher the degree of polynomial, more the integration is difficult. So of course you are not going to get such kind of more complicated integral, but you have learned that how the technique will work. So let us revise it. So the very important thing we have to simply see that whenever we have a polynomial and a linear to the power any constant or linear to the power any real number, we have to simply substitute this linear as t and extract this x from there, substitute x in the polynomial, and go on. So that's all for today's lesson. Thanks for watching.